Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When aryl methyl ethers, ArOCH3, are treated with excess high under heating, the OCH3 bond is cleaved, not the ARO bond. This is because the ARO bond has partial double bond character due to resonance with the aromatic ring, making it much stronger and resistant to cleavage. High cleaves the weaker OCH3 bond instead, producing the phenol, ArOH, and CH3I. Moving on to the next step. Identify the starting material. The substrate is 1,2,3-trimethoxybenzene, which has 3 OCH3 groups attached to the benzene ring at the 1, 2, and 3 positions. Moving on to the next step. Apply the reaction with excess high and heat. For each ArOCH3 group, high cleaves the methyl oxygen bond, ArOCH3 plus high ArOH plus CH3I. Since high is in excess, all 3 OCH3 groups are cleaved. And for the final step, the product is 1,2,3-trihydroxybenzene, pyrogalol, which has 3 OH groups on the benzene ring at positions 1, 2, and 3. Option A depicts a benzene ring with multiple OH groups consistent with the cleavage of all methoxy groups to give phenolic OH groups. Why other options fail? Option B. High does not substitute the methoxy groups with iodine on the ring. Electrophilic aromatic substitution of OCH3 by I is not what occurs here. Option C. Reduction to give CH3 groups does not occur under these conditions. High cleaves OCH3 to give ArOH plus CH3I, not ArOCH3. Option D. Formation of an OI species, hypodite-like product, is not a standard product of ArOCH3 plus high reaction. The major product is 1,2,3-benzenetriol, pyrogalol, matching option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.